Hello everyone. Uh, my name is Alian Debbarma. I'm from National Institute of Technology, Agartala. So I have finished my internship on embedded system at Emertxe Information Technology Private Limited. So the title of my project is the washing machine simulation using PICSimLab. So here we go. Uh, so this is the table of contents. First, there will be an introduction of the washing machine and the requirement of the project, and then we will go into the embedded C and its subtopic like keywords, data types, conditioning statement, operators, array, function, pointers, and macros. Then we will dive into microcontroller selection. We have selected PIC16F877F, particularly this microcontroller, and we will be knowing about pins of microcontroller and interrupts timers, and then we will go to the software requirements. What are the softwares we use in this project and simulating the washing machine? So we are using MPLAB XIDE, PICSimLab, and the compiler. This is used along MPLAB XIDE. It is called XC8 compiler. And then we will see some hardware peripherals like CLCD, buzzer, fan, switches. And then I will demonstrate a project. And then at the end, the conclusion. So let's go. So introduction to washing machine. So we all know what is washing machine, right? So a washing machine is an essential home appliance used for cleaning laundry automatically. It reduces manual effort by automating tasks like soaking, washing, rinsing, and spinning. Modern washing machines use embedded systems to control operations like water level sensing, motor control, timing, and user interface management. Simulating a washing machine helps in understanding real-world embedded applications involving controllers, sensor, and controller. Now, what is an embedded system? So, an embedded system is a combination of hardware and software designed to perform a specific task or function within a larger system. Unlike general-purpose computers, embedded systems are dedicated to particular operations like controlling appliances, vehicles, medical devices, or industrial machines. So, embedded system typically includes a microcontroller or microprocessor, input interfaces, memory, embedded software, firmware. Embedded systems are everywhere, from washing machines, microwaves, and smartphones to traffic lights and automotive control systems. Now, let's see what are the types of embedded system. So, embedded systems is classified into two categories. That is based on performance and functional requirements, and the other is based on the performance of the microcontroller. So under the performance and functional requirements, we have four types. There is these are real-time, standalone, network, mobile. And on the other, based on the performance of the microcontroller, we have got three types. These are small scale, medium scale, sophisticated. Right. So let's go to the next slide. Now let us understand what is embedded C. So embedded C is an extension of C programming language specifically designed for programming embedded systems. It allows developers to write code that interacts directly with hardware components like microcontrollers, sensors, and actuators. Key features of embedded C are Efficient and fast execution, direct access to hardware using register and ports, supports real-time operation, portable across different microcontrollers families. Embedded C is widely used to develop firmware for devices like washing machines, robotic systems, automotive controllers, and more. Now let's see what are the keywords present in C language. So there are total 32 keywords in C language. These are auto, break, case, care, continue, to, default, counts, which is constant, double, else, sorry, enum, extern, and so on till unsigned. So there are 32 keywords in C. These are the reserved word. Let's go below. So this is data types. So let's see what are the data types present in C language. So we have got three data types in C. First, primary, the second, derive, and the third one is user defined. Under primary, we have got void, in, care, double, float. Under derive, we have got array, references, pointers. Under user defined, we have data types of structure, union, enumeration. Right. So these are some of the C properties. I've got the conditional statements in C. It has basically if else switch. Alright. So conditional statements are used to make decision in C programs. They allow the program to execute certain code only when specific conditions are met. If checks a condition and runs code if it's true. Else runs code when the condition is false. Else if adds more condition options. Switch is used to compare a variable against multiple fixed values. Then we've got operators in C. So operators are symbols used to perform operations on variables and values. Types of operators. We've got arithmetic operators like plus, minus, multiplication, division, modulo. Relational, we've got this is equal to, not equal to, greater than, smaller than, and so on. Logical operators like and, or, not, assignment, equal to, and this plus equal to, minus equal to, etc. Bitwise and, or, and this all. These are the operators used in C programming language. Then we have got arrays in C. What is array? An array is a collection of variables of the same data type stored in contiguous memory locations. It allows easy access using an index. For example, in num. In nums is integer and this is a variable. This is an array, which means this array contains 5 elements. That is 1, 2, 3, 4. This is the element in an array. Alright. So this is of the same data type. So we can print this array here like this. Suppose if num 0, then we can print this one from this array. This one element, this first element will be printed here. And likewise, we can also print the second element, third element, and so on. We have got functions in C. So functions are blocks of reusable codes that perform specific tasks. They help organize the program, reduce repetition, and improve readability. For example, say we have in data type and we name the function 8, which the argument is passed integer a, integer b, and we return here a plus b. Now we store this, the return of a plus b in result, which is of integer type, and we pass the argument 3 and 5. So this will return us the addition of a and b, which is 3 and 5 in here. So this is reusable code that performs specific tasks. Right? This is a function. We've got pointers. Pointers are variables that store the memory address of another variable. They are powerful tools for dynamic memory arrays and functions arguments. Right. So in a here is equal to 10, and in start, or this is a pointer p is equal to address of a. So if you print here like this, what is the pointer p prints value at address. right? And we've got macros in C. Macros are defined using as defined. This is the syntax in here we use for the macro, and are used to create constant value or inline code replacement during pre-processing. For example, see, we have got 3.4. This is what we call pi. All right. So this 3.4 can be replaced by pi. The the uh, word pi. All right. That is how one can define macros, right? Same here. We can store x squared. This is x into x. This could be stored with this word, that is square x, and we can finally store in a variable which is of float data type. This pi, which is 3.14. This is 3.14. Now it is replaced with pi here, so that is why we can use pi here, and then instead of x square we use this down square x in here. So that is how uh, those are re- replaced using pi or square x. All right, this is called macros. Now let's dive into the microcontroller. So we have chosen the PIC16 F877 microcontroller. Oh, so let's see what is it. So PIC16 F877 is an 8-bit microcontroller developed by microchip technology, widely used in embedded system applications due to its simplicity, versatility, and rich feature. It belongs to PIC16 series, which is popular for beginner to intermediate level projects, especially in automations, robotic, and control system. Right? So why we selected this particular microcontroller, that is PIC16 FHM. So it is easy to program using MPLAB X IDE, supported by PICSimLab for simulation, excellent for learning embedded system, well documented with many online resources and tutorials. Now let's go. So the key features of our PIC microcontroller is we have got 40 pins here, dual inline package, 8-bit architecture, 14-bit instruction weight, flash memory 8 KB, RAM 368 bytes, EEPROM 256 bytes, non-volatile data. Input outputs we have got here 33 input output pins from port A to port E, and we have got 5 input output ports. That is port A, port B, port C, port D, and port E. We have got analog to digital converter, 10-bit 8 channel ADC. Timers, we have got 3 timers, timer 0, timer 1, timer 2. USART for serial communication, watchdog timer, and this microcontroller operates from 2 board to 5.5 board, right? So this is the typical picture of our PIC16 F877. We have got here the 40 pins dual inline package, right? See, we've got this all 40 pins in here. Now let's go. So defining input output pins. In PIC microcontroller, each input output pin can be as either an input or an output. This direction is controlled using trace registers. So trace stands for tri-state register. Each port like port A, port B, etc. has a corresponding trace register like trace A, trace B, etc. So we have got this port. Port A has a corresponding trace register trace A. Likewise, port B is having register trace B. Port C trace C, port D trace D, and port E trace C. So that is how each port has a corresponding trace register. Alright. So what are interrupts? So in embedded system, we have got this microcontroller embedded into it, and this microcontroller has got interrupts. What is an interrupt? An interrupt is a signal that temporarily halts the normal execution of a program to immediately respond to an important event. Once the event is handled, the microcontroller resumes its previous tasks. Interrupt sources. So we have got either internal interrupts or external interrupts. Also, we have got two classification, that is markable and non-markable. Right. Now let's go. Then we have got a timer. So what is timer? A timer is a built-in peripheral in control in microcontrollers used to measure time, create delays, or generate periodic events without blocking the CPU. Timers are based on counters that increase or decrease on its clock pulse and can be trigger actions when they overflow or match a set value. Key uses of timers: creating accurate time delays, generating PWM signals, example for motors, triggering interrupts at a fixed time, measuring pulse width or frequency, driving real-time clocks, schedulers, or event counters. So it's a continue of a timer. So PIC 16 F877 has three timers. That is timer 0, timer 1, and timer 2, which can be used as timer counter or PWM. And we've got this terminology. The tick. Tick is based on instruction cycle, resilience, length of the timer register, quantum, period of the tick, scaling. So it is a method where we can delay the process of going into as if required. So this is the block diagram that we have been shown during our intensive at Emertxe. So we use microcontroller, and also we use switches. So switch 5 in our intensive project, we use switch 5 for power. We can power on or off using switch 5. So basically we power on using switch 5. So switch 6 is used for pause or stop in our project. Switch 4 is given for the navigation. Door status is used in switch 1. So we have got CLCD, which is usually displaying washing machine status, and we've got this buzzer and fan or motor. So these are input. These four are input. The switches are input, and these CLCD, buzzer, and fan, these are output. And we've got a microcontroller here. So the software requirements in our project, or a project that is the simulation of the washing machine. So these are the software required in our project. So we've got this MPLAB X IDE, as I have mentioned earlier. So MPLAB X IDE is an integrated development environment developed by Microsoft Technology. It is used to write, build, debug, and program embedded C code for PIC, DSPIC, and ABR microcontrollers. So we have got MPLAB XZ compiler. So this is used for compiling the embedded C which are written in MPLAB X IDE. So MPLAB XC8 compiler is a C language compiler developed by Microchip Technology specifically for programming at PIC and ABR microcontrollers. It converts embedded C code into machine code, that is hex file, that a PIC controller can execute. And then we have got this PICSimLab software that is used for simulation. PICSimLab is an open source virtual simulator used to test and run programs written for PIC microcontrollers, especially with the MPLAB XC8 compiler, right, without using real hardware. It's like a virtual lab where you can load your hex file, connect simulated components like LEDs, motors, buttons, and watch how your embedded systems behaves. Alright, so these are the software requirements in our project in simulating our washing machine. Alright, let's go now. So this is the PICSimLab development board. We will be using this board. So we have got here this CLCD screen, the switches here, digital keypad, LEDs. These are the LEDs, fan, buzzer. Here is our microcontroller, PIC16 F877A. Alright, so let's go. So as I mentioned here, this is the CLCD screen. Now let us see what is CLCD, or which is called the character LCD. So a character LCD, which is also called LCD, is a type of alphanumeric display module that shows text, characters, letters, digit, and symbol on a screen, often used in embedded projects to display output or status messages. Common LCD modules. So we have got the two types, that is 16 into 2 or 20 into 4, which is 2 rows, 16 characters per row, or 4 rows and 20 characters per row. Main features based on SD44780 controller works in 4-bit or 8-bit communication mode. Communicates with microcontroller using data pins D0 to D7 and control pins RS register select, RW read write, EN enable. Right. So we have got the another peripherals, hardware peripheral, that is buzzer. So a buzzer is an electronic sound producing component used to give audio feedback or alerts. In washing machine simulation, the buzzer is used to indicate cycle start or end, error or warning condition, user notifications like lead open or program complete. It is controlled by a controller pin by sending a high signal to turn it on and a low to turn it off. So the other peripherals is fan. So the fan acts as a motor simulations with the spinning function of the washing machine and is controlled by the microcontroller. The fan represents a motor-driven component used to simulate drying or spinning after the wash cycle, indicate that the drum is rotating during rinse or spin modes. The fan is typically connected to a microcontroller output pin and is turned on or off by sending control signals in the embedded code. Right. The other hardware peripherals is switch. So in this project, simple push button switches are connected to port B, that is RBJ to RB5 of the PIC16F877 microcontroller to act as user input controls. These switches are used for starting and pausing the wash cycle, scrolling through the options, selecting modes, for example like weak, heavy, confirming choices. Each switch is connected to a specific pin and configured as digital input. When a button is pressed, the microcontroller reads a low signal, active low logic, and performs the corresponding function. Now let us go for a project demonstration. So I'll be showing you now the project, the working of the project. So we have got the LCD screen over here. This is called this LCD screen. These are the digital keypad. We have got switches. This switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. Alright, so these switches are used. These are the LEDs. We have got this fan, the buzzer, the microcontroller, that is PIC16F877. Now let's see how this washing machine simulation works. So I have coded using embedded C in MPLAB X IDE. This is the code for the simulation of the washing machine in PICSimLab. This is the main file, what source file, and the source file comes CLCD, this will keep it ISR main. So this is washing machine definition. So this is under main washing machine definition and washing machine function. These are the code that has been built here and made into an hex file. So this hex file is loaded in this PICSimLab. You can go to the file, load hex file here, and just select the hex file that we have built using MPLAB. Let us see how does it work. The screen is showing press key 5 to power on the washing machine. So this is the switch. We have got switch 0, so switch 1, 2, 3. So this is switch 5. Alright, let's press it. Now it's powering on washing machine. You can see here And then we have come into the washing program screen. It shows many options, like what is the option that you would like to choose. You can choose it from here. We can scroll it down using the switch for here. This arbitrary switch for, we can scroll it, press press it like this. We are gone to heavy now. Delicates, whites, stain, eucotones, and so on. We have got 11 to 12 options. Yeah. Now to select particular options, say whites, we want to select this option, that is the white. Then we have to long press switch for, it is arbitrary. So let us press. So I'm pressing the switch for now. That is the long press. Now we are into, see, we are into the other screen, that is the water level. So this is the screen that is this height. Uh, which option to choose for the water level? You can choose auto, low, medium, scroll it, high, maximum, and so on. So let us choose auto. I'm choosing auto here. Long press switch for, press it like this, and see, we are into another screen now. So it says press switch. So switch 5 to start and switch 6 to stop. If you want to stop it, you can press it in this, on this switch, that is the switch 6. And if you want to start, you press switch again. So I just want to start the program now. So see, the program has started. So the time is shown here, that is 1 minute 16 seconds. Now it is decrementing in here, and we can see the function is was. So it has got three phases, that is was. So sometimes it will show rinse in here and then speed at the end. So it says, you know, to to pause, we can press switch 5 here. Sorry, switch 6. That is this switch 6. Let us press if we can pause or not. So I press the switch 6 and it has to stop. It has paused for some time until I press switch 5 to resume it again. So even the fan has stopped right now. So to start it again or to resume it again, I have to press switch 5 in here. So let us press switch 5. See, now it has resumed again, and the timer has decrementing, started decrementing again, and you can see here the function has become rinse. So it is now the time for rinse. Now there is another function, that is switch 1. If you press switch 1 for a long time, it means the door is open and the warning will be displayed on the CL6 screen. That is to close the door. Let us see now. See, as soon as you press here, it will show you close the door. So this is the switch. If you press switch 1 here, it acts like a real door. Now as soon as the program has completed, it there is a buzzer that ring. You will get notified. It will say remove decloak, alright, and it is back to the washing program. That is how this whole washing machine simulation in PICSimLab works. Yeah, using the code that we have written in MPLAB XIDE, and we converted into it to an X file and then uploaded it load X file. So that is how, yeah, that is all about this project and the simulation of washing machine. Alright, let's go back to the slide. So my PPT has come to the conclusion. This project successfully simulates a basic washing machine using PIC16F877 and microcontroller in a PICSimLab program with Emertxe in MPLAB XID. User inputs were handled using switches RB0 to RB5, and outputs like fan, buzzer, and LCD were controlled through GPIOs. The simulation helped in understanding embedded system design, input-output interfacing, and the real-time behavior of the control-based application. that is it. That is the end of my presentation. So I want to thank Emertxe for giving me this opportunity to do an internship in your organization. I would like to thank the teacher who have guided me in this internship at Emertxe. Thank you, Emertxe. Thank you.